Hey guys, so of course in a follow-up to the last video, now I'm going to show you how to do that kind of dummy variable algebra. Let's implement that in a multiple regression model now. So as you can see right here, now I've included my pairing variables. On that board, I just didn't have room to do that. So notice that I have crude oil prices right there, regular gasoline prices, that's our dependent variable. So dependent variable, independent variable paired by a week and a state. This is like week ending June 5th. So I got weekly data. This is a big data set. There's almost 3,000 observations when I account for all three states. And so a good thing to always start off with, and this is why I had you start this way with your projects, is to make a scatter plot, which you can see here on my screen. Now, one thing that's kind of lame is that it's not clear where these points on this scatter plot come from. Do they come from California, Texas, or Massachusetts? Now, there's a cool trick you can do that I've done right here, and I'll pass along this spreadsheet so you can check out this formula more closely. But I use what's called an if statement right here. And let's zoom in on that a little bit so you can see it maybe better. Oh, will it show it all to us? So there it is. So I have if, and this says if this cell right here equals, right here it says California, that's that equals right there. If those two are equal, then give me the gasoline price. But if they're not equal, so it says give me D2 if those two cells are equal. But then it says give me an NA value, which is a special kind of value. It's like not applicable value if cell is not in California. So you can take a closer look at this and try to figure out the logic. That's a really good type of function to know how to use an if statement. It kind of underlies a lot of logic in computer programming more generally. So that's a great formula to get used to and is very powerful in Excel. So notice right here, I get an NA value because that is in California, but it's not in Texas. Now watch what I can do once went way too far out. There we go. Watch what I can do now that I have three variables, one for each state. Notice in this case, these are not dummy variables. This is just a cool way to make a scatter plot to show us what the different states are. So I'm going to go ahead and click on my independent variable to the left, Control Shift down arrow to get all the way down there. Then I'll hold Control, highlight these three, Control Shift down. And then watch what happens if I make a scatter plot that way instead of, I made this one just the same way you guys did, just the independent and dependent variable. But check out what happens if I make a scatter plot with those ones, with those special values. See, it colored the different series differently. Notice the shapes of these two scatter plots are exactly the same. The difference now is that I can see that the states really are showing a grouping pattern. Orange is Texas. And how do I know? Notice if I hover over those cells, if I hover over the blue, it tells me that's California. If I hover over the gray, it tells me that's Massachusetts. Orange is Texas. Notice now that that kind of says Texas on average has lower gas prices per oil price. Massachusetts is in the middle, and California has higher gas prices per oil price. But they have similar patterns, similar slopes, it looks like. So maybe we want to allow different intercepts, but the same slope. I'm going to say maybe Massachusetts is a tiny bit flatter, less of a slope. So we'll go ahead and try to see if we should be using a different slope for Massachusetts, especially just to show how that works. And then we can answer that question whether we should be doing it or not by looking at, is that variable that's allowing for a different slope in Massachusetts statistically significant? So one thing about just general organization, I like to make a history of what I've done in any type of data project. And this is huge in data science. Keeping track of what you're doing Because if you go find a mistake way down the road, at least you have a history of what you've done in the past and you don't have to start all over again. So I labeled this sheet scatter plot. And of course, that's what I'm putting in here, scatter plots. This is an initial look at the data. What am I dealing with right here? Now I labeled the next one regressions, which we'll work with here. And so I've got my data and state again. Notice I flipped around the order. Now I have my dependent variable far to the left, and I'm putting all of my independent variables to the right. That's just because of by the nature of the data analysis toolpack doing multiple regression. I'm going to want to highlight a big rectangle of independent variables, so I want those groups together. And this will make my life easier. I can also, maybe I think later of another independent variable I want to add. I can just stack those out to the right as I'm adding more to the model, which we're going to do right now, because notice we haven't filled these out yet. So I want ones and zeros. This is going to be my California dummy variable like it was on that sheet. So I'm going to go ahead and use an if statement. I'm going to say equals if. So if this value right here equals this value, and I'm going to go ahead and lock because I'm going to drag this to the right. And I'm going to drag it down so that I don't have to type this over and over again. That's why we'd like to use a formula here. So I'm going to drag this to the right. I don't want that blue box to move to the right when I drag to the right. I want it to stay there. So I'm going to lock B. I do want it to move down, so I will not lock the 2. Also, when I drag it over, I do want this to go to the right. And so it looks like that's the locking, but we can always check that again later. So we're going to want a 1 here if that's true. So the first number we put in is, if this conditional statement is true, what number should I put in this cell? We want a 1 if that's true, because if it's in California, we want it to be equal to 1. We want a 0 if it's not true. So the second number you put in is the number you want if it's not true. So let's close that. Enter. So I got a 1 there, which is what I should get. If I double click that down, oh, nope, I didn't lock something right. So when I double click down, oh yeah, I want to lock this California in, right? I thought I might be missing something. So let's put a $sign here, because that red is matching, right? That red E1 is saying that's that red box. We want that box to be locked so it doesn't move down, but we do want it to move it across for when we go over to Massachusetts. So I'm just going to lock the 1 there. Try that. Double click it down. Okay, that looks like it fixed it. But let's make sure by scrolling down, see what happens when we get to Texas. Boom, they all changed to 0 when we get to Texas, which is what we want, right? Because now that we're in Texas, the California dummy variable should be 0. So let's go back up, drag this to the right, and I should get a 0 there because that's not in Massachusetts. I don't want to drag it right here. We'll do that in a second because that's that special interaction variable, right? Let's double click this town. That's good, that's zeros. But let's check the bottom because that should turn into 1s when we get to the bottom. Look, Massachusetts, now it's 1. So that's a quick way to make those dummy variables in a big data set. And a great formula to get used to, a really powerful formula. You can do crazy things with if statements in Excel. Now let's try equals. What are we going to do now? We're going to multiply Massachusetts by crude oil price, which is right here. That one we don't have to lock anything because that's just going to follow us down. That's all zeros until we get down to Massachusetts. Right there, now we have those oil prices repeated over. And remember, that's going to allow Massachusetts to have its own slope. Okay? So let's go ahead and run a multiple regression now. So I'm going to hit data. Come on, data analysis. Drag it over. Oh, my data analysis disappeared on me. So I'm going to do tools, Excel add-ins, analysis tool pack. Okay. Come on. Sometimes if you go away and come back, it magically appears. Boom. So there I am. data analysis, regression. Okay. Well, our dependent variable is going to be regular gasoline price. So click regular gasoline price, shift control down arrow, or shift command down arrow if you're on a Mac. I always hit command because I'm on a Mac, but I always say control. But command and control, command Mac, control Windows. Now let's go click in our input range. We're going to include all 4 X variables here. Remember, we had 4 independent variables for this model. So I'm going from D to G, and then I'll do shift control down. And now notice all the numbers match and stuff, so that looks good. Let's put this, oh no. I wrote over it by accidentally clicking, so let's try that again. I'm going to do all 4 independent variables, control shift down arrow. Got them back in there. This time I will click out of there right away so I don't accidentally click somewhere else. I'm going to drag way up here because now I'm just picking where I'm going to put my results, right? Let's go ahead and put them output range. I remember to put my cursor in this time for the first time ever, even though I made that mistake. That just slowed us down just as much anyway. But let's put our output right there. We push OK. Oh no, non-numeric data. Oh, what did I forget to do? Click labels right here. So that's what happens if you forget to click labels, because Excel's like, hey, California is not a number. But if I click labels, and then I cross my fingers again, boom, sweet, it happened. So let's check out some of our regression statistics. This regression model, now that I'm using 4 variables, it's kind of harsh to say variable 1, variable 2, variable 3, variable 4 explain 72% of the variation in gas prices. I would say this regression model explains 72.34% of the variation in gasoline retail prices across states. Regular gasoline retail prices is what we use. So that's our R squared. Now we've got all of our coefficients down here. Let's find out if these coefficients are statistically significant. Notice we have, that is our slope for crude oil price. When crude oil price increases by 1, regular gasoline price increases by about 2.5 cents on average in the data set. That's what that says right there. Notice, does that matter? Boom, 0. We haven't seen that before. That p-value is so small that Excel is just rounding it to 0. Which it has to be really small to do that, because look at the p-value on the intercept, which it's not rounding to 0. That p-value has 184 zeros before you get to a number after the decimal point, and it's still not rounding that to 0. Implying that if it's so tiny it's rounding it to 0, that is a tiny p-value, and that is a super statistically significant variable. And it makes sense, because that's the main input to gasoline prices. Now California, we saw in our scatter plot that California had higher gas prices on average than Texas and Massachusetts. In fact, on average, the gas price holding crude oil price constant is about 57 cents higher in California than in Texas. Why then in Texas? Because remember, Texas is the baseline equation. Massachusetts has even higher gas prices on average relative to Texas, 60 cents extra. Okay, if we wanted the California intercept, I could write that down here. Notice to get that, I would go equals baseline intercept, Texas intercept, plus my estimate of beta 2. That's the total California intercept. Massachusetts intercept. Whoa, I think that maybe, okay, equals baseline plus Massachusetts right here. Notice that this slope on the oil price is the same in Texas and California, because we're not allowing the slope to be different in Texas and California. We are, however, allowing the slope to be different in Massachusetts. So I might write, well, let's not have to spell Massachusetts again. Tricky. Massachusetts slope, that's going to equal California / Texas slope. That's that beta 1 from the last video, but it's B1 because it's our sample estimate. Plus, slope is going to be a little bit smaller in Massachusetts, so I'll click that there. And so that's our Massachusetts intercept. Although on average Massachusetts is higher from the intercept, it grows more slowly with crude oil prices than Texas and California prices do, because we're decreasing that slope a little bit by adding a negative number or subtracting from it. Notice all of these guys are statistically significant, so that looks like this is a pretty good, we picked good variables. All of those variables we picked matter in a statistical sense. All right? So that's how we find those different things, and if you want to play around with this, then you can interpret different slopes. Another thing I want to point out, you are required in your project to add some new control variables. Notice I didn't have to do that much work to get my hands on these control variables. I did have to have panel data to do this, but you can think of other dummy variables for time series data, for example. Like if something happens that's important at a certain date, you could have zeros before that date and ones after that date. Maybe there's a pandemic or something, and everybody starts staying at home and going crazy making videos. So you can have that in time series. You could also have it in cross-sectional data. Maybe you just have all the states. Maybe there's something special about the Midwest. Make a variable called Midwest that will be 0 in states that are not in the Midwest and 1 in states that are in the Midwest. So this, again, is how we implement a more complicated model with dummy variables in Excel. So this really is paired up with that last video, so I encourage you to kind of watch them together, and that should really help out. All right? I'll see you guys later.